Good evening, sir.
Good evening.
Good evening, sir.
Yeah, good evening, madam.
Sir, you can start, sir.
Yeah. Yeah. Can you see the screen sharing, Ajay? Okay. Look at the first problem. So let me take up the problems based on the refraction concept, which as explained in the previous two classes. We have explained the refraction, how it is taking place in the case of a plane surface with Slens law concepts, lateral shift, normal shift, and total internal reflections, isn't it?
Yes, sir.
Yeah. Let me take the problems based on that. A beam of monochromatic blue light of wavelength 4200 angstrom in air. What is the wavelength in air they have given? 4200 angstrom. What is the wavelength of the water they have given? 4/3. What is the wavelength they are expecting in water? In water. So this is the wavelength in air medium, right? This is the refractive index of water. What is refractive index of water they have given? NW 4/3. What is the wavelength in air medium? 4200 angstrom. They are expecting to find what is the wavelength in water. So this is the refractive index they have given for water. How do you define refractive index in terms of wavelength? You know that refractive index is inversely proportional to what? Wavelength. Correct? No?
Yes, sir.
So what is refractive index of air divided by refractive index of water then? It should be wavelength of water divided by the wavelength of air, because it is inversely proportional. So in refractive index, if you are taking air by water, in wavelength you have to take water by air. Refractive index of air is 1, you know that. Refractive index of water is 4/3. What is the wavelength of water you have to calculate? What is the wavelength in air medium? 4200 angstrom. This 3 goes up. So can you simplify for wavelength in water? So this becomes 3/4. Do the cross multiplication of this 4200. So this is equal to what? How much it is?
So 4150, sir.
Hey, 3150, I think. Check.
Yes, sir. 3150, sir.
So 3150 angstrom. So which is the right option?
So option C.
Option C, yeah. Okay. Look at this. Second problem. There is a glass plate. Wavelength is incident at what angle? 60 degree.
So 60 degree.
Reflected and refracted rays are?
So mutually perpendicular.
They are expecting to find what is the refractive index N. Let me write the diagram for this. Let me say this is the interface. This is air medium. This is some given medium. Okay. That given medium means it is a glass. You have to find what is the refractive index of this glass medium. What is the refractive index of air, my dear? Now, at what angle the ray of light is incident? This is the incident ray, right?
So it's incident at 60 degrees, sir.
Yeah. So if I say this is the normal, what is this angle equal to?
Sir, that's 60 degrees.
Yeah, this is I is equal to 60 degree. Now they are telling that the ray is undergoing both the reflection, this is reflected ray, and also it undergoes refraction. This is angle of refraction, right? What is the another data they have given? This reflected ray and refracted ray are perpendicular. So what is the meaning? What is the angle between these two rays? 90 degree. You know that angle of incidence is equal to angle of reflection. So if this is 60 degree, then definitely this should be equal to what? 60 degree. Now, what is this 60 plus 90 plus R?
180 degree.
Very good. Very good. Can you tell me what is R? $30 degree, no?
Yes, sir.
Yeah. Can you tell me the Slens law for this? Can you tell me the Slens law for this?
So
Refractive
sin
index
9.
of air into sine 60, no?
Yes, sir.
Equals to Ng into sine R. How much
Yes,
you
sir.
got for R?
So 30.
30. Sine, a refractive index of air is 1. Sine 60 is root 3 by 2. Ng value you have to find. Sine 30 is 1 by 2. So 2 and 2 will get cancelled. So what is the refractive index of glass? Root 3. So which is the right option?
So B.
Yeah. So Ng is equal to root 3. So second option is the right answer. You have any doubt?
No, sir.
Okay. Let me take up the next problem.
Yes, sir.
Yeah. Yes. Look at this. Velocity of light in glass whose refractive index with respect to air is 1.5. So what is the refractive index of glass? 1.5. What is the velocity of that light in glass medium? 2 into 10 power 8 meter per second. And there is some liquid. We don't know what is that liquid. In that liquid, the velocity is how much? What is the velocity in that liquid? 2.5 into 10 power 8 meter per second.
Yes, sir.
Out there, what is expecting? What is the
Sir,
refractive index of the liquid? Yeah,
Yes,
you
sir.
have to simplify this for me, Appa, because it is a basic question. You know that refractive index and velocity are inversely proportional, right? Isn't it?
Yes, sir.
If refractive index is inversely proportional to velocity, can you tell me what is refractive index of glass divided by the refractive index of liquid? It should be velocity of,
So liquid by the velocity of gas, sir.
yeah,
Glass.
velocity of glass. Now, what is refractive index of glass? 1.5.
So 1.5.
Refractive index of liquid you have to find. The velocity of the liquid is 2.5.
So 2.5 into 10 to the power of 8, sir.
8. Whole thing divided by velocity of the glass is 2 into 10 power how much? 8.
Yes, sir.
So this 10 power 8 and 10 power 8 will get cancelled out. So on simplification of this, on cross multiplication, what is refractive index of liquid? 1.5 into 2 divided by how much? 2.5. So refractive index of liquid is how much? 3 divided by 2.5. How much it is? 1 point.
So 1.20, sir.
So which is the right option?
So option C.
Option C. If you have any doubt, please let me know. Okay. Yeah. Look at this. A ray of light passes through 4 transparent media. mu1, mu2, mu3, mu4 as shown. This is mu1. Second medium is mu2. This third medium is mu3. This is mu4. Now, the surface of all medias are parallel to each other. Please look at these wordings. Emergent ray is parallel to what? Incident ray. So what is the meaning? Incident ray is parallel to emergent ray.
Yes, sir.
Incident ray is parallel to emergent ray. Please remember the refractive index of incident ray must be equal to the refractive index of which ray?
So emergent ray, sir.
This is what I've explained in lateral shift, right?
Yes, sir.
In the case of lateral shift, the incident ray and the emergent ray are parallel only if the refractive index of the mediums are same. So if the
Yes.
incident ray and the emergent ray are parallel, you have to remember the refractive index of the incident medium. Refractive index of the emergent medium must be the same. Looking the diagram, which is the incident medium? Which is the incident medium? Incident medium is mu1. Which is the emergent medium here? Mu4. So mu1 is equal to what? Mu4. So which will be the right option?
Sir, option D.
Option D. Correct, no?
Yes, sir.
Yeah. Let me take up the next problem. Look at this. Look at this. A ray of light is incident at glass water interface. At what angle? I. This is the incident ray. Finally, it emerges parallel to the surface of water. Here it is coming like this. What is the value of mu g they are expecting? They are expecting mu g, question mark. Yeah. Look at this. If this is I, this is R, this is R. What is this angle equal to? If the ray is grazing the surface, what is this angle equal to? (90°),
Sir,
no?
90 degrees, sir.
So let it be that is equal to R dash. That is equal to R dash. Yeah. Now this is glass, this is water, and this surrounding medium is air. If they have not mentioned, you have to take it as air. Now, can you apply the Lenz law? Can you apply the Lenz law for glass water?
Yes, sir.
Yeah, tell me the Lenz law for glass water. Apply the
Sir,
Lenz
I
law for
into, sir,
glass
I,
water.
sir,
Online class.
sir, I into Ng is equal to R into N or W.
Ng into sin I
Yes, sir. Sin I
is
into
equal to
Ng,
Nw into
sin R, sir.
sin R. Then, can you apply the Lenz law for water air?
Yes, sir. Sir, so NW into sin R is equal to
Lenz
NA.
law for water air
Yes, sir. So NW into sin R is equal
is
to
equal to Na
NA into sin 90, sir.
R dash.
Sin R dash. Sin 90, which is 1, sir.
Yeah. Now, this NW sin R and this NW sin R are equal means I can equate these two parameters.
Yes, sir.
So on equating that, can I write that as Ng sin I is equal to Na into sin R dash? Ng I have to calculate, sin I we don't know, right?
Yes,
Sin I also we don't know. So do one thing. Do one thing. From this, you calculate what is Ng. From this, you calculate what is R. What is Nw they have given? 4/3. Sin R we don't know, which is equal to refractive index of air is 1 and sin R dash. What is R dash equal to? What is R dash equal to? 90, no?
Yes, sir. The sin 90 is 1, sir.
So sin R value will be equal to 3/4.
Yes, sir.
So this is sin R value. This is sin R value. Now, you substitute sin R value And can you calculate what is Ng in the first equation? In the first equation? Because answer is in terms of sin I only. You keep sin I as it is. So from this, I'll keep Ng as it is. Sin I as it is. What is NW they have given? 4/3. What is sin R value I got? 3/4. So what is Ng into sin I? 1, no?
Yes, sir.
If Ng sin I is equal to 1, can I write this equation for Ng as 1 by sin I?
Yes, sir.
So which is the right option?
So B, sir, option B.
Option B. Yeah. Look at this. What is the ratio of the thickness of the two plates of the two mediums? Six is to 4. Correct, no?
Yes, sir. 6 is to 4, sir.
6 is to 4. The light takes equal time. The light is going to take equal times in passing through them. Then what is the refractive index of medium B with respect to
Sir, A.
medium A? Yeah. Refractive index of medium B they are expecting with respect to A, that is NB by NA. Yeah. What is the
Sir.
basic definition for time?
Sir, distance by velocity, sir.
Distance by velocity. T equals to. Distance can be taken as in the first medium, I will take it as x. If it is here, it is only 1 into x. Suppose if there is a refractive index in that medium, then it should be n into x. So distance is given by the formula n into x. Velocity of light in the medium I can denote with c. So what is the formula for the time in terms of refractive index and the thickness? Time is equal to refractive index into x divided by what? C.
Yes, sir.
Here you have to remember the distance is given by n into x if there is a medium. Because you know that refractive index and distance are inversely proportional. So refractive index in A is divided by the refractive index in the given medium means distance traveled in that medium and the distance traveled in that air. This is the relation between the distance and the medium. So you have to do the cross multiplication. So distance traveled is n into x in a given medium. But they are telling that the time intervals are same. The time interval for the first case and the time interval for the second case are same. What is T1? N1 into X1 divided by C. What is T2? N2 into X2 divided by
So C,
C.
sir.
So C and C are
So cancelled.
cancel out. So what is first case is this is 1, this is 2. 1 N2 or AB. So what is N2 by N1 from this equation? x1 by x2. So what is x2 by x1? So the ratio they have given, right?
Yes, sir.
x1 by x2 is 6 by
4, sir.
4. So n2 by n1 is equal to x1 by x2. What is x1 by x2?
So 6 by 4, sir.
6 by 4. So this is nothing but 3 by 2. What is 3 by 2?
So 1.5.
So what is the right option?
So 1.5.
1.5.
So
Yeah, tell me.
doubt, sir.
Yeah.
Sir, since they have given thickness, sir, can't we take it like this, sir? Refractive index is directly proportional to the thickness, or refractive index of B with respect to A will also be, sir, refractive index is inversely proportional, sir. So refractive index will be of B with respect to A will be same as the thickness ratio of the thicknesses, sir. So it'll be still 6 by 4, which will give us 1.5.
Yeah. You can like that. You can do like that. So they're expecting N is inversely proportional to what? B, thickness. So if you want N1 by N2, I can directly write D2 by D1.
Yes, sir.
So you'll get the same answer. Yeah, you can do that in that way also. Look at the next problem. Ray of light is passing from where to where? Vacuum to medium. Refractive index is mu. So when it comes from vacuum to medium, what is this Lenz's law? Mu is equal to sine I divided by sine R. Angle of incidence is found to be twice the angle of refraction. I is equal to 2R. So I can take I as 2R. Whole thing divided by what? Sine R. They have given the condition that R is equal to a what? I is equal to what? 2R. You know the formula for sine 2R? Off angle formula? Multiples and submultiple. Sine 2R into cos R. Sine
Yes,
2 theta formula is 2 sine theta cos theta. Sine 2 theta is 2 sine theta cos theta. So what is sine 2R? 2 sine R into cos R. So sine R will get cancelled out. So mu is equal to 2 times of cos R. So R will be equal to, athva cos R will be equal to mu divided by 2. So R will be cos inverse of what? Mu by 2. But they're asking you to find what? They're asking you to find what? Angle of incidence.
so
No?
angle of incidence, sir.
You know that angle of incidence I is equal to how much? 2R. This is the condition. What is R? What is R? Cos inverse
Sir.
mu by 2.
Yes, sir.
So angle of incidence is 2 cos inverse mu by 2. So which is the right option? Option B. Okay. Take up the next problem. Be very careful here. ray of light is passing on the spherical glass paper. It makes what angle? Alpha with the normal. Alpha with the normal. Refracted is taking place in the medium at what angle? Beta. What is the angle of deviation of the emergent ray from the direction of the incident ray? From the direction of the incident ray. From the direction of the incident ray. Yeah. Now I have to consider one spherical glass paper, right?
Yes, sir.
So let me say this is a spherical glass paper. This is the center I'm going to take. Now there is a ray of light is incident. From the center O, I'm going to write one normal. What is the incident angle?
Sir, alpha, sir.
Alpha. Now this undergoes a refraction. This refracted ray makes an angle beta. What is the refracted angle they have given? Beta, correct?
So
No.
beta, sir.
Now this refracted ray is incident on the other side of the sphere, right?
Yes, sir.
So this is the normal. This angle must be equal to what? Angle of incidence for what?
So the second surface.
Yeah,
Sir.
this is same as this, right?
Yes, sir.
And it undergoes refraction here.
Yes, sir.
Since it
And
is symmetry,
so that will be alpha, sir.
this will be alpha. Suppose in the absence of the sphere, how the ray should travel? The ray should travel straight, no, in the absence.
Yes, sir.
In the absence of this sphere, the ray
Yes,
would
sir.
travel along straight.
Straight, sir. Yes, sir.
Because of this sphere, instead of traveling along red color line, it has got deviated and it is moving at delta. What is this delta tells?
So angle of deviation, sir.
Delta tells the deviation. Now, if this is alpha and this is beta, this angle should be alpha minus beta, right?
Yes, sir.
If this is alpha, this is beta, also
So
we
alpha
can tell this
minus
is
beta.
also equal to
Alpha minus beta.
alpha minus beta. One of the geometrical concept tells exterior angle is equal to sum of the interior angle.
Yes, sir.
So exterior angle is equal to the sum of interior angles. So exterior angle is nothing but delta here, that is deviation. Sum of the interior angle is alpha minus beta. This is 1. This is the another interior angle. Alpha minus beta plus alpha minus beta. So delta will be equal to 2 times of what?
So alpha minus beta.
So what is the deviation produced by the ray?
So option B, sir. 2 times alpha
Option
minus
B.
beta.
Yeah. It should be an isosceles triangle. Okay.
Yes, sir.
Because from the center, if this I say this is equal to radius, this is also equal to radius. Since it is an isosceles triangle, these two angles must be equal. If it is coming out with beta, it should be incident with beta because of the property of isosceles triangle. Any doubt in this problem?
No, sir.
Okay. Look at this. This is also quite important. They have frequently asked this type of question. There is one rectangular slab. There is a rectangular slab of what refractive index? Mu.
So mu
Over another slab of refractive index. Over
3.
the another slab of refractive index.
3, sir.
3. Refractive index is 3. Both slabs being identical in dimension. If a coin is placed below the lower slab, for what value of mu will the coin appear to be placed at the interface between the slabs when viewed from the
So top.
top? Let me write the diagram for you. I think this was explained in the synopsis. How many slabs are there? 2 slabs.
So 2 slabs, sir.
They have same dimension, right? Same dimension means if the thickness of the first slab is x, this is also equal to what? X. Now the refractive index of the first slab we don't know. Let it be mu. What is the refractive index of the second slab?
3.
This you have to find out, mu. Now below the top, below the lower slab, there is a coin. Below the lower slab, there is a coin here. This is the coin. When you look this coin from the other medium normally, this coin appears to be raised and that coin is going to be placed at which point? It appears to be at where?
Interface.
At the interface of this. So this is the image of that, right?
Yes, sir.
This is called apparent depth, no? Correct,
Yes,
no?
sir.
Apparent depth.
Yes, sir.
This apparent depth is also equal to what? X, no. If the image is formed
Yes,
here,
sir.
the apparent depth should be equal to x. You know that refractive index is real depth by apparent depth. So what is the total apparent depth here? Real depth by
So real
refractive
depth
index
by
for the first slab plus real depth by refractive index of the
second slab, sir.
second slab. Isn't it? What is the total apparent depth?
So 2x.
Hey, apparent depth, only x.
Sir, sorry, sir. Apparent depth. X.
Yeah, what is the real depth for the first slab?
Sir, x.
What is the refractive index of the first slab? Mu. We have to
Mu,
find
sir.
that. What is the real depth for the second slab?
Sir, x.
What is the refractive index for that apparent depth?
3, sir.
I mean,
3.
3. Can you simplify for mu? Because x is common, no? We can cancel out. 1 equals to 1 divided by mu plus 1 divided by 3. So 1 by mu is equal to 1 minus 1 by 3. That is 2 by 3. So what is mu?
So mu is 1.5, sir. Option C.
Yeah, 3 by 2. That is option C. You got it?
Yes, sir.
Okay. Can you read the problem for me?
So a coin is kept at the bottom of an empty beaker. A traveling microscope is focused on the coin from top. Now water is poured in the beaker up to a height of 10 centimeter. By what distance and in which direction should the microscope be moved to bring the coin again in focus?
Correct. Correct. Whenever the water is poured, there will be a normal shift. See here, actually coin is kept in the empty beaker initially. If I say this is the empty beaker and this is the coin, in the upward, if I focus the traveling microscope, it will be seen at exact distance. Let it be x. Okay. Now, if I pour the water up to what height? Up to what height?
10 centimeter.
Yeah.
And
Up to 10 centimeter, the water is going to be poured out. So 10 centimeter. Because of this medium, there will be a shift in the coin, right?
yes, sir.
There is a shift in the coin. What is this shift here? This is the image of the coin. That is the image of the coin. What
Coin.
is this distance called? Apparent depth.
So apparent depth.
Apparent depth. What is this shift called?
So real depth.
Normal shift. From year to year, it
So
is
yes,
real
a
depth.
normal shift. Yes, a normal shift.
So normal shift, real depth, and this is the apparent depth. Now, you can find what is this apparent depth, right?
Yes, sir.
Real depth by
So
refractive index. What is the real
refractive
depth of the water medium?
So x.
X.
But I think the data is incomplete here. We don't know what is n, right? You do one thing. Let me give this data. Refractive index of water is how much? 4/3. Let us take this given. Given refractive index of water is 4/3. So real depth of water is how much? 10 centimeter. Refractive index is 4/3. So it is 30/4 centimeter is the apparent depth. Therefore, can you tell me what is the shift in the object? That is called normal shift. Real depth minus apparent depth.
Apparent depth, sir.
So that is 10 minus 30/4. That is 40 minus 30. That is 10/4. 10/4 is 5/2. 5/2 is.
So 2.5.
So by what height this object, this coin has raised?
So 2.5 centimeter.
So the actual coin has raised by how much?
2.5
2.5.
centimeters.
So what is the condition then? In order to get the image of the coin, I should move the traveling microscope by what distance? If the object coin is moved by 2.5 centimeter, Here, the traveling microscope position has to move by the same distance, no? So in order to get focus again, coin shifted by a distance of 2.5 centimeter. Since the coin gets shifted by 2.5 centimeter, to again focus, traveling microscope should get move upward, right?
Yes, sir.
By what distance it has to be move upward?
So 2.5 centimeter.
2.5 centimeter upward. So which is the right option?
So option C, sir.
Option C. Yeah. Got it, Ajay and Varsha?
Yes, sir.
Okay, okay. So by what distance the coin has got shifted in the upward direction? By the same height the traveling microscope should get shifted upwards. Yeah, almost the same type of problem here. Similar to that. Similar to that. But only the plane mirror is there here. Plane mirror is there. Okay. Now, there is a refractive index of water 4/3. What is the height? What is the height of the water? 10 centimeter. Image appears to be at 10/4. So what is this distance? 10/4 means? 10/4 means 2.5 centimeter, right? So for the mirror, O dash is the object. For the mirror, O dash is the object. So for this plane mirror, object is not O. Because of the normal shift, the object appears to be at O dash. It is shifted by what distance they have given? 2.5. So what is this remaining height? 7.5, right? So what is the distance of O dash from the mirror? What is the distance of O dash from the mirror?
12.5.
12.5 centimeter. You know that in the case of a plane mirror, object distance is equal to what? In the case of a plane mirror, object distance is equal to image distance. If that is the condition, if the mirror to object is 12.5, from the object to image, it should be the same. Because for plane mirror, object distance and image distance must be the same. So which is the right option?
Option B.
12.5 centimeter, and also please remember it is always going to be found behind the mirror. For plane mirror, image will be always behind the mirror. Yes, any doubt, Ajay?
No, sir.
Yeah. See here, this is most confusion. I think I'd given this in synopsis also. Wavelength in two media is lambda 1 is 3500 angstrom, Second wavelength is 7000 angstrom. They're expecting you to find the critical angle. You know sin C is equal to N1 by N2, right? Correct, no? How refractive index and wavelength are related? Lambda 2 by lambda 1.
Yes, sir.
Please remember, this is not only
Sir,
a
inversely
formula, this is
proportional,
only
sir.
a formula. But
Yes, sir.
while solving the problems, you have to keep this ratio. You have to keep this ratio in such a way that it should be less than 1.
Yes, sir.
I think I've explained this in synopsis. Sine of the critical
Yes, sir.
angle is always equal to the ratio of refractive index or ratio of the wavelength. But remember that ratio should be always
So less than 1.
less than 1. So this is only you have to remember for the formula sake. But for this problem, I should write sin C is equal to, I should write lambda 1 by lambda 2 or lambda 2 by lambda 1.
So,
I should write lambda 1 by lambda 2 or lambda 2 by lambda 1.
lambda 2 by lambda 1, sir.
Lambda 2 by lambda 1 ego. How it is
Sir.
possible?
So sorry, sir. Lambda 1 by lambda 2, sir.
That is what I am saying. This is only a formula sake. But
Yes, sir,
remember,
yes, sir.
the ratio
Lambda
may
1
be
by
anything.
lambda 2, sir.
Yeah, the ratio may be anything, either lambda 1 by lambda 2 or n2 by n1 or n1 by n2. But that ratio should be always less than 1. Okay. So here you should write lambda 1 by lambda 2. Don't write lambda 2 by lambda 1. Ratio should be always less than 1. In such a way that only you have to substitute. So it is 3500 by
So 7,000.
7,000. So 3500 by 7,000 will be 1 by 2, right?
Yes. Yes, sir.
So what is the critical angle then?
Sir, 30 degrees.
Sin 30 will be 1 by 2, no?
Yes, sir.
So it should be equal to 30 degree.
Yes, sir.
So remember,
Option C.
only for the formula sake, we are giving this. But in the problems, you have to keep the ratio in such a way that you should get less than 1. Because sine function is not defined for more than 1. Sine function is not defined for more than 1. Yeah. Look at this. They have given the light which is going to incident from which medium to which medium? Air to glass. As shown in the figure, this angle is 60 degree apart. This angle is 60 degree. It is incident at 60 degree on the lateral surface. So that it undergoes TIR, total internal reflection. Total internal reflection. What is the refractive index of glass? 1.5. What is the refractive index of air? 1. How much time would it will take travel to cover a distance of how much? 1 kilometer. Yes.
1 kilometer, sir.
Yeah. What is the formula I had given? Direct formula now for the time. Mu into x. Refractive index of glass medium into distance traveled. Divided by what?
Sir, C, sir.
C. Speed of light.
Yes, sir.
This C represents speed of light. Be careful. Now you don't know what is mu. You know that the refractive index is equal to 1 by sin C. Sin C represents critical angle. C represents what? Critical angle here.
Critical angle.
Here, the ray is going to grace like this. So this represents the critical angle. So mu is equal to what is critical angle? Sin 60. Sin 60 is root 3 by 2. So mu value will be equal to what? 2 by root 3. So you got the refractive index of that, how the critical medium is taking place.
Yes, sir.
You substitute that mu here. Don't substitute this mu. This is for glass fiber. At one end of the glass fiber is there, right? That refractive index is 1.5, not this medium.
Yes, sir.
This medium refractive index we are calculating. This fiber refractive index is given. So
Yes.
what is the refractive index? 2 by root 3. What is the distance it has traveled?
Sir, 1 kilometer, sir.
1
1 into 10
kilometer
to the
means 1
power.
into 10 power 3.
Yes,
By
sir.
speed of light is how much?
3 into 10 to the power of 8, sir.
So 2 divided by 3 root 3 into 10 power 8. When it comes up, it becomes minus
So
5.
10 power minus 5, sir.
10 power minus 5. You simplify this. Do approximate calculation. No issues. 2 divided by what is 3 root 3? 3 into 1.73, right?
Yes, sir.
So what is 2 divided by 3 into 1.73? 3 3s are 9, 3 7s are 21, 5 point something, right?
Yes, sir.
Yeah, what is 2 divided by 0? 5.19? It is 0 point something like 3.
So 0.38, sir.
0.38 into 10 power minus 5.
Yes, sir.
Or I can take this as 3.8 into 10 power minus 6, right?
Yes, sir.
What is 10 power minus 6? Micro. So 3.85 microsecond. So which is the right
Yes.
option there?
So option D.
Option D. Got it?
Yes, sir.
Okay. Let me stop at this stage, Appa. Still 5 more problems are there. So in the next session, we'll complete these 5 problems. Then I will take up that refraction through prism. So that completes plane surface. After completing this remaining 5 problems, we'll have a formula discussion on refraction through prism. Is it fine?
Yes, sir.
Okay, Appa. Then I will stop at this. I will wind up the class now. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you.